Okay, so now we're back, and in this chapter, we need to learn how to add vectors by components, and we need to be able to get the components. So we need a little bit of a math background. So in this particular case, we're going to learn about two things for math. We have to learn about the Pythagorean theorem, which has already been stated. So the Pythagorean theorem, and this only works for a right triangle. If I have a right triangle, what I'm talking about is a triangle that looks kind of like this. So the right triangle means it's 90 degrees. And we usually call one of the sides A and one of the sides B. And we will always designate C as the longest side, which is also called the hypotenuse. Okay. So the Pythagorean theorem is a relationship on a right triangle between the base and the height and the hypotenuse. In the same case, we need to use a little bit of trigonometry. So with trigonometry, it's basically the ratio of sides. So that's what trigonometry is. So with trigonometry, we draw a triangle. And when we draw the triangle, again, it's going to be a right triangle. And I'll always have my angle touching the x-axis. So with this, we don't use the words the letters A, B, and C. We use new words. So the word opposite deals with the angle. So if I'm going to look for the side of the triangle that's opposite this angle, so over here would be the opposite. And if I'm going to be looking for the side of the triangle that's adjacent, meaning next to this angle, the word adjacent, referring to the angle, is down here. Okay. And once again, the hypotenuse doesn't change. So the hypotenuse is here. So there are three rules in trigonometry which talks about a ratio between two of these sides. And most likely you've seen them and used them sometime in the past. So one of them is called the sine of the angle, and that's the relationship between the opposite side over the hypotenuse. And there's another one which is called the cosine of the function, cosine of the angle, which is the adjacent over the hypotenuse. And there's another sign, there's another function which is called the tangent of the angle, and that's going to be the opposite over the adjacent. So with these three trig formulas, and with the Pythagorean theorem, we can take any triangle at all and we can break it up into the x and y components, and we can later take those components and put it back together and get one resultant vector. So if I had a vector that looked like this, this is the east and this is the north. Let's say somebody, whoever, in the scouts or whatever, they have to hike and they have to follow this path. Let's say they're going to hike, okay, they're going to hike 1 kilometer, and the angle there, km, and the angle there is going to be 60 degrees. So that particular vector is pointing both between the east direction and the north direction. So what we want to do is break this vector down into its components. So what I mean by that is, if this was happening, my question is, how far east? The person started here, and the person ended here. How far east did they travel? Well, instead of going from this point to that point, I could travel along this way. And then, once I get there, I could travel along this way. So you see, what we've just found is that this piece is called the adjacent side, and the adjacent side is equal to the x component. And this piece over here, it's called the opposite side, opposite from this particular angle, and the opposite side is equal to the y component. Okay. So using what I know about trigonometry, I could say that if a scout were to go and hike 1 kilometer at an angle of 60 degrees between the north and the east, then I could go and use the rule, and I could say that the cosine of the angle is equal to the adjacent over the hypotenuse. And if I plug that in and solve it, it's going to come out to be the adjacent side is equal to the hypotenuse times the cosine of the angle. So if I just plug that in, the hypotenuse is 1 kilometer, and I'm multiplying that by the cosine of 60 degrees. Now if I do that on my calculator, it'll come out to be 0.5 kilometers. And that's going toward the east. So the person who is hiking this way has hiked 5 meters to the east. And then over here, to get the opposite, I could use the formula sine of the angle equals opposite over hypotenuse. And I could rearrange that and say the opposite equals the hypotenuse times the sine of the angle. And if I plug that in, the hypotenuse is 1 kilometer, and I want the sine of 60 degrees, and that is going to come out to be 0.866 kilometers, and it's going to the north. Okay. So when we talk about taking a vector and breaking it down, we are breaking the vector into the x and the y components. What I'm saying is, this particular vector is 1 kilometer at a 60-degree angle northeast. Okay, so that's what we're starting with. We're saying that we started with 1 kilometer at 60 degrees between the north and the east. That's the real component right there. That's our vector. And if I want to break that vector down, then I have to find the x and the y components. I have to find out something that's equivalent. So if I took this vector, 0.5 kilometers east, and I take this vector, 0.866 kilometers north, I get the exact same thing. So you see, here, if you look at the green vectors, we could add them tip to tail. So I take the 0.5 right here, I take the 0.5 kilometer east vector, and I draw the tail right near the tip, and I then add these together, and I add 0.866 kilometers going to the north. And in this case, if I take those two vectors and add them tip to tail, and did the Pythagorean Theorem with these two numbers, I would end up with this value right here, which is a hypotenuse. So in the last problem, we added two force vectors. we had a force going to the east and a force going to the north, and we added them tip to tail, and we did the Pythagorean theorem. In this case, we're going to take one vector, 60 kilometers, going 60 degrees northeast, and we're going to break it down into the x and the y components. And that's the only way we can add vectors. Vectors cannot be added like numbers. Vectors have to be added using components of each. So how's another way we can use those formulas? So let's say we try to add two vectors. So let's say we're going to add these two vectors again. Okay, so let's say the first vector. Usually they make up a story. In all physics, they make up a story. So let's say we're starting right here, and this is our starting point. And let's say that's Boston. So let's say some friends get onto a new boat, and they're going to take their boat out into the ocean, and they're going to go to the east. So let's say they go 15 kilometers east. Okay. So I don't know why I drew that picture. I should have just written it here. 15 kilometers east. Okay. And then say, the next thing they want to do is they wanted to go and they're going to turn that boat a little bit, and then they're going to sail or cruise 7 kilometers north. Okay. So in that case, when they get here, they would start to go towards the north a little bit. Okay. I could say find the resultant vector. So the resultant vector is the result when you go from the overall start to the overall end. And as I said, these people who are cruising out there, they're now going to go 7 kilometers this way. So that's 7 kilometers north. Well, where are they going to end up? They're ending right here. So this is the ending point. And so we want the straight line distance from the start to the end, and it's going along this line. So as you can see, what I'm getting here is a triangle, and I want to know everything about that hypotenuse number right there. So what's everything to know about the hypotenuse? Well, I want to know the length of this. So I want to know the length of the hypotenuse. How would I use that? The Pythagorean theorem. So I'd use this formula, a squared plus b squared equals c squared. And I'd go and I'd plug it in. So let's say a is the base, it's 15 kilometers. I'm going to square that. Plus, what is b? B is the height, it's 7 kilometers. I'm going to square that, equals c squared. I do that on my calculator, and what's coming out on my calculator is that c squared is equal to 274 kilometers, which is squared, and that equals c squared. So I need to find c. What I need to do is take the square root of both sides. And when I do that, it comes out that c is equal to 16.55 kilometers. Okay. So that right there is called the magnitude of the resultant. Remember, a vector is made up of two different parts. One part is just the number. This is the number right here. So the magnitude of the resultant is just the number. And we also need to get the angle. So how could we get the angle? Well, there's one formula that I haven't used yet. And I'm just going to. So a moment ago I had this picture. And the picture looked something like this. It said, here's the Cartesian coordinate system. It said we're going to start here. It said we're going to go and we're going to take a boat out 15 kilometers east. And then we're going to turn and we're going to go to the north 7 kilometers. See how I'm trying to draw it somewhat to scale? When I drew this first line of 15, I set the scale. And then 7 is going to be drawn a little bit smaller than half of 15. I didn't take out a ruler, I'm just doing it roughly. So the thing I'm looking for is, we've just ended here. A resultant is the straight line distance from the start to the end. So I'm looking for this piece right here. I just did this calculation on this side, and I can tell you that the hypotenuse has a number of 16.55 kilometers. But I also want to know in which direction. If there was an emergency, I had just said that possibly this is a scenario of where some friends get into a boat, and they take the boat cruising, and they cruise 15 kilometers to the east and 7 kilometers to the north. I said this was Boston. So you see, if this was the case, and this was Boston, then if an emergency happened here, then we want help immediately. So possibly there's the Coast Guard from Boston. I don't actually know all the details here, but if the Coast Guard is leaving the same place where you started, the Coast Guard has to know in which heading to fly a helicopter or to send an emergency boat. So we want to know what this angle is very, very exactly. We want a very specific angle. We don't want to just say they're going to be between the north and the east. If I was out there in the middle of the ocean and someone said, well, they're in this quadrant here between the north and the east, I would not feel too confident that they would find me because it's huge. So I want this exact angle. How would I do that? I would use the formula that I've written down, one of our trig formulas. The tangent of the angle is equal to the opposite leg over the adjacent leg. Okay? And to solve for this, I need to take the inverse tangent function if I want to get the angle. So the inverse tangent function looks like this. Tangent minus 1. The opposite leg is a number 7 kilometers, and the adjacent is a number 15 kilometers. And we are just going to do that on our calculator. When I take 7 divided by 15, I get a decimal point of 0.466. And if I hit the second function tangent, my calculator will tell me that that angle is going to be exactly 25 degrees. And it's going between the north and the east. So a vector has two things. We need both things. This is part of the answer, and this is also part of the answer. Okay? So the Coast Guard would be told to go and rescue that boat, and the Coast Guard would be told to head at a 25-degree angle northeast and go travel 16.55 kilometers. So what I've just done there is I've taken the idea of components and I've added them up, and I've formed a triangle, and I'm showing you how to use the Pythagorean Theorem, and I'm showing you how to use the tangent function. In this case, it's actually the inverse tangent function. So let's say we're given these three vectors. I am going to go and I'm going to hike 10 kilometers north. I'm also going to go and hike after that 5 kilometers east. I'm also going to go after I do that, and I'm going to hike 5 kilometers at a 37-degree angle between the north and the east. Okay, and I'm not necessarily going to do that all in one day, but that is my goal. That's what I plan to do. If I had to draw this thing, I would draw the axis at the Cartesian coordinate line. Okay. I would try to draw my three different vectors. I can do these tip to tail in any order. I don't have to worry about doing this first and this second. I can do them in any order, but I'll do them in the order you see them. So I'm going to go 10 kilometers. So that right there is 10 kilometers. So this one's done. I'm then going to go and I'm going to hike 5 kilometers east. So it should be half of the length of this line. That one's done. That's 5 kilometers. And then I'm going to go and I'm going to go at an angle of 37 degrees. So right here I can draw the Cartesian coordinates again. And a 37-degree angle may look like this. And that is 5 kilometers here. Okay. So, and this is 37 degrees. So So what I could do is I could try to do this by components. So if I look at my x components and look at my y components, I make a little table. Okay, so one of the things I've done here is I've gone 10 kilometers to the north. So if I do that, I haven't gone in the x direction at all. When I walked to the north, I didn't go east or west. So this would be 0, and this would be a positive 10 kilometers. So those are the components of this vector. It has 0 in the x direction, it has 10 in the y direction. I could then look at this component. Here, I'm only moving to the east. So if I look at the one going to the east is a positive 5. And it's not going north or south. The person hiking here is just hiking to the east. So this would be 0 kilometers. And finally, now this is the most important part, what's happening here? Right here, the person is hiking somewhat to the east and somewhat to the north. So they're doing this. They're going over like this, and then they're going up like this. So what you're seeing right there, let me zoom way into that, if I can. I don't think I have much more room to zoom. So for that particular piece right here, what we see is we see a triangle forming. And you have a base here, and you have a height here, and the hypotenuse is 5. So you're looking at that triangle, you can see the hypotenuse is 5 kilometers, and you can see the angle is 37 degrees between the north and the east. So how would you go about figuring out that? Well, we've done that today already. This piece here, you can say, let me use the cosine function. So the cosine function is the hypotenuse, the cosine function is the adjacent side over the hypotenuse. So you could plug that in. You could solve it for the adjacent side. So the adjacent side came out to be the hypotenuse, which is 5, times the cosine of the angle. And that angle is 37 degrees. That number is going to come out to be 4. So this is going to come out to be 4 kilometers. And in the same case, if you did the height, you would find out how to get the height. You would say that that's the opposite leg, and you would take the hypotenuse and you would multiply it by the sine of the angle. And what is the hypotenuse is 5, so with your calculator take 5, multiply it by the sine of 37 degrees. You have to be in degrees here. And if you do that, you're going to come up with a number of +3. So right on this little section here, instead of walking from the lower left-hand side of this triangle to the upper right-hand side of the triangle, instead of walking 5 kilometers in a straight line, the person could walk 4 kilometers to the east. So let me go here, +4. And then they could walk up this line, which is 3 kilometers to the north. So in the y direction, that's 3 kilometers. I want to draw the diagram again. So I said I went like this, 10 kilometers. And then I went like this, 5 kilometers. And then I went like this, 5 kilometers. But this one was at an angle of 37 degrees. So a moment ago, we just did some calculations, and we decided that the person who walked this went over this way 4 kilometers, and they went this way 3 kilometers. So the person who's doing this hike, they're starting down here and they're ending up here. Is there another way that they could do such a hike? And the answer is yes. They could just start here and they could walk over this amount and then they could hike up this amount. Okay. How far over did they walk? Well, up here they walked over to the right 5 kilometers, and here they've walked over to the right 4 kilometers. So 4 kilometers and 5 kilometers add up to 9 kilometers. Okay. And how far did they end up traveling to the north? Well, here we had 10 kilometers, and here there was an additional 3 kilometers. So 10 kilometers plus 3 kilometers is 13 kilometers. So the person who hikes this, if they wanted to start at their home base, they could go east 9 kilometers and they could go north 13 kilometers. And then what we would have is a brand new triangle. And I'm just going to make this a little bit dark. I'm just going to go right over it. So you see what I'm doing in green here? I'm trying to show you this big triangle. Okay. So if we went to the east and if we went to the north, another way we could get there would be this way. Let's look at these numbers for a moment in our table. If you add up the y-x components, 0 plus 5 plus 4, that gives you a plus 9. Add up the y components, 10 plus 0 plus 3, that gives you plus 13. The plus here, under the x direction, a plus sign means you're going to the east. And under the y direction, a plus sign means you're going to the north. Okay. So what you're looking at here, this is the total x component, and this is the total y component. So with those two components, you now can add up the vectors, and let me back this off a little bit. So again, let's look at this big green triangle. The base is 9, which is right here, and the height of it is 13, which is right here. So how would we figure out the hypotenuse of this thing? We would use the Pythagorean theorem. So to figure out the hypotenuse, we would say a squared plus b squared equals c squared. And if we plug that in, it would be 9 kilometers squared plus 13 kilometers squared equals c squared. And when you do the math out, c is going to come out to be a number 15.81. So that right there, that number is the length of my resultant vector. That's how long the distance is from the overall starting point to the overall ending point. And what about the angle? When we talk about the angle, I'll find the angle right in here. So what is the angle that a person could hike in this one direction and end up at the same ending point that the other people did? Well, what I would do is I would say the inverse tangent function is going to give me the angle. So the angle is equal to the tangent minus 1 of the y piece. In this case, the y piece is the 13, the total y. So I'll say 13 kilometers over the x piece, which is 9 kilometers. And if I do that on my calculator, the angle is going to come out to be 55 degrees, and it's between the north and the east. So that's how to do a problem like this. It's not a just one-step problem. It takes a lot of steps. So as you can see what's happening here, there's many ways to start at one location and to end at a different location. There's many ways. As the coordinates were given, if we followed these original coordinates here, we would hike 10 kilometers north, 5 kilometers east, and then 5 kilometers 37 degrees. So you see, we could follow the original path, which going up here, and then going this way, and then going that way. it would end there. We could also come up with an alternative path. So what we did is when we broke down everything into its x and y components, if we added up all the x components, we get 9. If we added up all the y components, we got 13. So another way we could do it is we could go to the starting point and hike along 9 kilometers east, and then hike 13 kilometers to the north. It would end up at this ending point. Yeah. But the third way to do it is, if we look at the math, we could do the Pythagorean Theorem and come up with the magnitude of the resultant vector and come up with the angle of the resultant vector. And that's the best way. That will be the easiest way. So if we had the capability of traveling in a straight line, if we were capable of flying like a bird, we could go in a straight line from our starting point to our ending point. And that bird would end up flying along this green vector right here, which has a length of 15.8 kilometers, and which has an angle of 55 degrees between the north and the east. And if I've drawn it at all close, if you look at the way it's drawn, if you draw it all closely, it should kind of look to scale. So just the things I want to point out, look at the 9 kilometers. It's a length that is shorter than here, the 13. 13 is a bigger number, so you'd expect a longer line, and I see that. The angle was 55 degrees. If you look at this triangle, that angle does look like it's steeper than 45 degrees. I'm not putting a protractor up to it, but just by graphically drawing this somewhat to scale, that angle should be approximately 55 degrees. If I set the scale at the beginning, if this length of this line right here was 10 kilometers, then as you can see, this one here is much bigger. Okay, it's not quite double, but the answer was 15.8, and this actually does look like it represents 15.8. So if somebody were to do this, they would end up walking 10 kilometers plus 5 kilometers plus 5 more kilometers. They would walk through a distance of 20 kilometers, but they would only be displaced from their starting point by 15.8 kilometers at a 55-degree angle.